All right, so 50 questions, early algebra questions, one of the last videos on this material that I plan on making. Maybe we get to lessons at 50, 60, 70, a review of this material, perhaps. But if you've done the first 20 lesson sets, first 25, this should be old hat. I'm hoping that just like an old Schwarzenegger movie, you get total recall. I will be talking briefly about some shortcuts that I take that maybe I haven't mentioned yet with some of this material, but otherwise it's pretty straightforward. I hope you do most of it as a mental math exercise, and then maybe write all your answers down. You're doing mental math, and then star anything that you're not sure of. Go back and write out what you need to write out and see if you've gotten a correct answer. I will not be checking my work. I have plenty of people out there who let me know if I make a mistake, and hopefully I don't make too many, but I do make more when I'm talking to you than if I just look at the problems and do it without multitasking. Talking to you is a little bit of multitasking, so usually make a couple of errors because I'm either too close to the material, don't see the numbers properly, probably should be wearing glasses, but I'm not. So let's have at it. The first problem is write the equation of a line. And my computer has blanked out on me a couple of times here for some reason. I hope it doesn't. I went to IT and it's like going to the doctor. Something's wrong until you go to the doctors, and then whatever it is doesn't seem to be happening. So, all right. What's different about this particular problem? I put all these problems on the board last Friday. And so some of them I got started with, so I'll have to do some erasing as we go, but I'm not doing this video again. So here we go. All right, so what's different about this? The X value is smaller. The second one I'm giving you is smaller than the first. And that's the first time I've done that to you. So I like to take the second one. Otherwise, we've got a change in X that's negative. I want to avoid even thinking about it. So X minus 8 plus 50 is how I would start that. And then I can say, how do you get from 8 to 10? Change by 2. How do you get from 50 to 1 down 49? And there is our first problem done. Hope you can just write that on your answer key. Tomorrow is a test, 50 problems, same 50 problems. Just going to mix up the order that I do them in. And hopefully you're keeping track of where you make mistakes and studying that tonight. Trying to get ready for tomorrow. All right. Algebra is the study of numerical processes. I think we're ready for that. I think every time we've written a y equals, that has been our first step. So in this case, get rid of x1, bring in y1. Next time, get rid of y1, bring in y2, get rid of x2 minus x1. That's the conversion process. The only problem is we do linear so much that we don't see the conversion process in the other functions, which if they start from a particular x value and y value, we can write just as quickly and easily. And we'll be doing that in future lesson sets. But the early algebra ones, we're only doing it for mostly quadratic, maybe square root, absolute value, but that's good coffee today. All right, so I'd already done this problem, so I'm sorry you're looking at it already. So factoring, I like to say write as a product. So if tomorrow during the test you ask me what WAAP means, that means you haven't looked at a dozen of the videos that I've assigned, and maybe I'll let you know that. Be a little embarrassing, but maybe that's what it takes. Why did I put this problem here? Highlighting what? The first rule of writing products. And I've said it continually throughout the semester, highlighting it one more time. Take out what's common. And if you do, you get a difference of 2 squares. You get, well, I don't want to do them yet. You get 36x squared minus 25y squared. And the difference of 2 squares can be written as the sum of the square roots times the difference of the square roots. And we've looked at that extensively in other videos. So moving on. Mental math. All right, I did a bunch of mental math until the computer died on me. Let's hope it doesn't. So there you go. Maybe you didn't have time to look at that. And if you didn't, great, because I want you to practice this using mental math. And I think I had 3x squared equals 5x on this problem. All right, so that's what I think the original was. So I'm going to flip it, 9 over 4, take a square root, 3 over 2, cube it, 27 over 8. Hope you just can do that on your answer key. I hope you know that one of your answers is x equals 0. So if you factor it out of the equation and you forget to write x equals 0, no credit tomorrow. All right, but if you do know that process, which we'll do the whole process in a second, but if you know one of your answers is 0, then you're basically taking one of them out of the equation, and then you can see your other answer is 5/3. Now, what did I do? I moved 5x to the other side, subtracted it, set it to 0, and then I factored the x out. 3x minus 5 equals 0, and I know that one of the factors has to equal 0, hence our answer. All right, so let's get rid of that. Maybe I should have left those answers there. You should be able to do this in your head. You should be able to subtract 5, which gives you 7, and you should be able to divide by -4, and you should be able to move this negative sign into the numerator. If not, pay attention to what I just said. Play it again, Sam. See what happens. If you play it again, you get one more rep, maybe just enough to connect those synapses. All right. Vertex -2, so I think we start with that. Most every time we're writing a function, I think we make a 0 out of that first number so that we can bring in the second, and now we have a correlation. And the smallest I can get from the squaring process is 0. That is the smallest number you can get, and now we can see -2 makes that happen. Now we're looking at squared change. In a linear function, you're looking at linear change. We're looking at squared change. And when I drop a 0 in there, 4 plus 7 is not taking me to 3. So that 4 units of change didn't work. What does work? -4, and I don't care if you put that on your answer key. It's the thought process that I am correcting. Okay? Obviously, it's nicer if it's written that way. Okay, but I'm not going to penalize you if you don't, because I've been highlighting the process, and I have to trust that you know how to reduce a fraction. Because there's other places that I can see if that's true or not. So I'm not worried about it there. All right, this problem. I'm seeing 2 root 15. Why? Because I'm seeing square root of 6 as the square root of 2 times the square root of 3. And I'm seeing the square root of 10 as the square root of 5 times the square root of 2. I intentionally put the 2 at the end that time because I'm seeing by definition the square root of 2 times the square root of 2 equals 2. If you don't believe me, do the square root of 9 times the square root of 9, and you'll see it's 3. All right, so this is 2. That's root 15. If you don't believe me, do 2 times 3 equals 6, and watch what happens when I do the square root of 4 times the square root of 9. I get the square root of 36. The only time a square root times the square root isn't a square root is here. You get rid of the square roots because what are you doing? You're squaring a square root. Disappears. Does not disappear here. Okay, enough said. So hopefully that's a piece of cake. All right, this one here, you might have to put the marker to pencil. So marker to pencil, the marker to the board or a pencil to a piece of paper. There, said that right, finally. I'm going to multiply by -5, and I'm going to take a shortcut here. So I'm going to make that -5. That becomes -15, and that becomes +40. Okay, and this may not be the exact problem that was on the board because I erased it till my computer crashed, and I just made something up on the fly. So I'm seeing -13y. I'm seeing 26. And I'm seeing y equals -2. So would have been easier to plug it into the bottom one, but now I've got to plug it into the top. And I get -10, -4, -14. So x is -2. Okay. So I think I did this problem before, which is why I set it in that order. If I bring the -4 to the other side, then this other side becomes +10, right? And so 5 times negative 10, excuse me. 5 times negative 2 is negative 10. Awkward explanation there, but we're moving on. Okay, so what do I see here? I see if I'm going to reduce a fraction, division gets reduced by multiplication. So I'm going to write that as a product. And if I do, I see 2 is common, and I can see it was 5x minus 3. And hoping that you can see that that is a binomial square at this stage, which happens to be 5x minus 3 squared. All right, so you might have to put a little marker to the board or pencil to paper for that problem. But now I can see that one of these cancels. Okay, and so that becomes a reduced. This is where it matters that you reduce it. That's what I'm looking for an answer. Okay, so g of a, f of x equals negative 6. What that's really saying is, I don't care what the x value is. We're going to turn whatever number you give me or whatever statement you give me, we're going to turn it into the number negative 6. And I don't care what you put here for g. Oh, I should have done g of. I don't care what you put into g of x. I'm going to get negative 4 because I'm doing g first here. All right, so what's g of a? Doesn't matter what I give you. It's negative 4. So this becomes f of negative 4. Doesn't matter what I give you. It's going to turn into negative 6. So that's your answer. Okay, now, what's another name for g of x? It really means y equals. Doesn't matter what your x is. Y equals negative 4. There's the x-axis. Here's the line y equals negative 4. My altitudes are negative 4. I don't care what x you plug in. I do not care. Plug it in. Comes out as negative 4. That's the discussion we want to have. All right. So this is a problem that I generally don't do mental math, but I'm going to have some fun here and do mental math. So I've got minus 14, I got 15, that's 1 on this side, so I've already got my x equals 6. That wasn't too bad. So what did I do? I multiplied this equation, and since I have it on the board, I think I can do this right now, problem number 12. I'm going to multiply this by 6 because it cleans up the fractions. And if I do, this one becomes 2 times bigger. This one becomes 3 times bigger. And I made a mistake. So it's a good thing I'm doing this out. I usually do it out. Equals 2. For some reason, talking to you, I made that into an x value. Don't know why. Age. Senility. Yep. So now that I did that, and that's 6, right? If I multiply by 6, that's what I should have got. I don't know what that 2 was over there. More senility. All right. So I did see x equals, and now I can see that it's not that. So I get minus 14x equals negative 9. So x equals 9/14. And I cleaned up my carelessness. Hopefully, on your answer key tomorrow, I already made one. And a problem like this, I actually did it out. Because I know I make careless errors with that one. But I tried again anyway. I still made a careless error. All right, so that one's done. mx plus b. I like doing these in my head too, for practice. All right, so that's going to get me positive 15 minus 36. 15 minus 36 is minus 21. Minus 21 over 4, I think, is my answer. But this is another one where talking to you, I make careless errors. So minus 3/4 x, let's check it. Let's say I'm done the test. I'm done. Positive 15/4 minus 36/4. 26/5 minus 21. I'm feeling better now. Write as a product, x squared minus 8x plus 12. Well, I do believe we have the marker, and I can make x squared appear. And I know a couple of numbers that multiply out to be positive 12 and give me a negative. So I know I'm going to get one of those each and every time. And that brings my mind to 2 and 6. And I'm feeling pretty good about that. I usually put this down. I usually don't do that as mental math. So let's get rid of some of these things. So I do write down 10x to the 6th. Let's get rid of that, or I'll say it's a negative. 10x to the sixth, I see minus 14x to the third. I'll separate it a little bit just in case I get an x to the fifth or an x to the fourth. I see a minus 10x to the sixth. Oh, wow, I like that. Oh, that was accidental. And I see minus 10x cubed. Well, I think my answer is minus 24x cubed. Yeah, I hope I didn't make a mistake. But just keep going along. If I did make a mistake, I'm human. Everybody can make mistakes. That's what this class is about. It's about our humanity. All right, 16. So I'll do that in my head. I know I'm going to get minus 3x squared. I know that's going to be minus 4 times minus 3, so I think that's going to be 12x. I think that's going to be 4 times minus 3 minus 12 plus 5 is minus 7. I think that's my answer. But let's check. So let's do minus 3 times x minus 2 squared is x squared minus 4x plus 4. All right, now in the textbooks, you have a minus b squared, and then in highlighted, you have a squared minus 2ab plus b squared, and then people turn the page, and then they usually do a minus b times a minus b. I think you should cut to the chase and know that. And if you've done the first 20 problems, you know I highlight that all the time. All right, so I doubled that product. All right, so where was I? I was here. There's the plus 5 at the end. And now let's check my answer. I like minus 3x squared. I like 12x. I like minus 12 plus 5. I'm moving on. All right, so the inverse. You know, that means the inverse. I like to isolate, if this is an equation with just the variable showing up in one location, I like to think of this as solving an equation. And how do you solve equations? Inverse operations. So if I put a number in, I subtract 5 and subtract 4 and divide by 5. Divide by 5 was the last thing I said. So I'm going to multiply by 5. And then I'm going to add 4. And then I'm going to check it real quick with a number like 14. 14 gets me 2. I can see that. Does 2 get me 14 here? Absolutely. I'm moving on. That's a correct answer. Let's get rid of this stuff. All right. 2x squared minus 20x, vertex, minus b over 2a. Do that in your head. You got a 5. Put it in the middle term, cut it in half, and 5 should get you minus 50. Okay. Roots. Well, now we've got the roots. If we've got the vertex and we got the a value, then we have the roots. X equals 5 plus or minus the square root of 50 divided by 2. This was factorable. No kidding. Right? No kidding. So maybe I'm just in the habit of doing this so much, right? That 5 plus 5 is 10 as a root. And so is 5 minus 5. So is 0. And if I looked at it, we're setting it to 0. And that's one we already did earlier. I think. Didn't we cover one like that already? Maybe not. Yeah, I think we did. So 0 equals x times 2x minus 20. Most people would factor out 2x. For these problems, I always just take an x out. I can see the number 10. I can see the number 0. Those are our roots. All right. But I like this process because there's an awful lot of quadratics that if you have the vertex and the a value, 5 seconds, done. All right. So what was the graphing form? Let's see, where was I? Well, it's certainly 2, right? We got 5, so x minus 5 squared. And we got minus 50 here equals 0. That allows me to do what? That allows me to do 50 divided by 2 plus minus square root adding 5. Right? That allows me to do that quickly, and I don't have to write that out. I can see it. Sketch 2x minus 5y equals 20. These are a product. 2 times x, 5 times y. What do we say about products? Make them 0. So if you make the first one 0, you can see that we get a negative 4. If you make the second one 0, you can see we got a 10. Connect those dots. You got a line. Sketch. Okay, I'm not going to sketch it. This one here goes through 5, 2. So you just write 5, 2, and it's going up. So put it there, over 4, up 3, right? And that's why it's called slope point form. You're supposed to see that point, you're supposed to see the slope. Doesn't hurt to change your x by 4, call that 9. Doesn't hurt to add 3 to 2. And then if you put a 9 in and a 5 in, doesn't hurt to check it to build your skill level. And now it's right. Why did I write my quadratic in that form? Because that's how I graph. I know I'm at 0, 5. I know I'm going down at 12 to 1 at that instant. And I know it's cup shape up. So therefore, I know that that's a positive x value. So I simply take 12 and divide it by 4 to get 3. Then I plug 3 into the middle term and I get minus 36. I cut it in half and add 5. And those are the shortcuts that I take for sketching that quadratic. Of course, I don't do this. I simply do that. And I know I'm going down at 12 to 1. And many of the earlier lesson sets show you why. All right, V shape up, 3, negative 21. I like the y-intercept, so I always put a 0 in. The magnitude of this is 3. 6 minus 21 is minus 15. That's a bigger number than that. So hopefully no carelessness. 4x squared, I think I was asking you to sketch that. Trying to do some of the problems on the last lesson set that came at the end of the lesson set. And I know a lot of people didn't finish that lesson set. I said finish it up for homework. No guarantee you did it for homework. So I'm moving it earlier in this lesson set. 4x squared equals 8. Hope you got a plus minus. That tells you how many answers there are. There could be 2 imaginary. They come in pairs, but this has to have 2 answers unless it's sitting on the x-axis. And we call that a double root, right? All right. But we got a couple of answers coming our way. What are they? Plus minus the square root of 2. Cosine A for this problem. Yeah, you can see it lower right corner there. So 100 minus 49 means this is minus the square root of 51. And that's why I put it in the second quadrant, because I wanted to see if you remember the minus sign. Because if you make the mistake here, it won't cost you. Cost you tomorrow when it's a test. So what is the cosine of angle A? 51 over 10, excuse me. Square root of 51, because that's the area. That's the area. And so, well, no, that's the area was minus 51. So that's the length of that segment right there, of that triangle. All right, moving along. All right, quadratics. Quadratic like this, you hope you can factor it. And obviously you can, or I wouldn't have given it to you this way unless I wanted you to complete the square, which maybe I should do right now. So we got a minus minus, talked about that before, I think. And so we got a 1 and an 11. We set that to 0 and our answers are 1 gets me 0, 11 gets me 0. We move on. Let me do this problem very quickly in case this wasn't factorable, but you had x squared minus 10x. Let's make it plus 12. Now it's not going to work, but I could write it as x minus 5 squared minus 25 plus 12 equals 0. And then we can see minus 13 becomes positive 13. Coefficient of 1, so dividing by 1 is 1. You obviously don't have to show that. The plus minus and the 5, and you got the roots of that. All right. Hopefully you didn't make a careless error. Again, binomial squaring. I'm hoping you see 49x squared. I'm hoping you're doubling that, minus 28x. And I hope you're squaring that as 4. Doing it with this problem. I hope you're seeing 16a squared b squared. I'm hoping you're seeing minus 12 becomes minus 24 abc. What if this was a squared? What would change? If that a term was squared, well, this is to the 4 now, and that's 24 a squared bc. And then we square the last term, 9c squared. 1/4 minus 1/9. The subtraction of 2 numbers can always be written as a product. I don't care if you give me the sun minus the moon. I'm going to give you the square root of the sun plus the square root of the moon times the square root of the sun minus the square root of the moon. So in this case, I'm going to give you 1/2 plus 1/3 times 1/2 minus 1/3. You do it out, watch the middle terms cancel, and you'll get that calculation. 2/3 to 10 halves, I guess. I guess that's a 2. Now, what did I ask? Oh, distance. So I'll probably giving you the distance formula, because I usually get that after the writing that trig function over there, cosine of A. So what's the distance from 2 to 8? 2 to 10, 64 units of change. What's the distance from 3 to 2? 1. So I'm looking at the distance as a right triangle. Oh, let's see, what quadrant would I be in? Distance doesn't matter. Distance is always positive. Quadrant 1, 2, 3 to quadrant, I'm still in quadrant 1, 10, 2. So what I'm doing is this. I moved 8, I went down 1. So what's that distance? Square root of 65. Using Pythagoras. Square areas, right? Square areas, square areas. Okay, done plenty of times in earlier videos. Let's get rid of this. Let's get rid of this too. Got a class coming in soon. There we go. So that's gone. Perpendicular, well, 9/3 is the slope, perpendicular slope. So 3 times what? Pass through, I don't know what let's have it pass through high there. Okay, so x minus h plus t. All right, that's perpendicular to this line passing through high there. Okay, you don't believe me? Then solve. 9y equals minus 3x, that constant doesn't matter. And we get y is equal to minus 1/3 times x. That's the original slope. What do we have to do for the perpendicular? Negative reciprocal. So down 1/3. What's perpendicular to down 1/3 over 1 up 3? All right, hopefully you can see the perpendicular relationship. Down 1/3. So the rise becomes the run becomes the rise, and we're going in the other direction. We're not going down anymore. Negative slope, we're going up. Perpendiculars seem to act that way. All right. Didn't do many variation problems. Algebra 2 class, it's an Algebra 1 question. Doesn't take long to learn. Y varies directly as x. Y equals kx, and inversely as z. So we plug 3, 12, and 4 in. So we got a 4. We got a 3, so that becomes 3k, and that's a 12. All right, 4 times 12 is 48, divided by 3. Should have done division first. 3 goes into 12, 4 times 4 is 16. So I now know k is 16. All right, so I'm going to change my x's, my y's, and my z's. My y is now 6. My z is now 10. My x I don't know. All right, so 10 times 6 is 60 equals 16x. So let's go 30 equals 8. Let's go 15 equals 4. So it looks like I got 15/4 is my x value. Hope I didn't make a careless error there, because voice is getting tired, brain's getting a little tired, but moving on. Name that tune, vertex. Well, if it's a vertex, we're doing a quadratic. So I'm going to write x plus 1. That gets rid of -1. Bring in 1. Let's make it a quadratic. Let's square. What's the squared change from -1 to 6? 49 units of squared change have to be canceled out because my x2 is 6. And when I drop 6 in, I hope you can see 49 units of change does not take me from 1 to 3. 2 units of change takes me from a value of 1 to 3. All right, good enough. FBI. Well, I can't use the FBI anymore. We're starting to get rid of that department. So using FB and I, trying to get you to learn the quadratic formula any way I can. Minus B plus minus the square root of B squared minus 4 times the F and the I all over 2F. Now, if you don't get that fraction bar under both of those situations, wrong. I guess that's where the major mistake comes. But there's your quadratic formula. That's going to solve for t in this instant. In this instance, that formula gets the job done. Quadratic formula is, for the most part, very cumbersome. It's useful in some situations to find out if you got a real or imaginary root, but there's other ways that are much quicker for solving quadratics. So I tend not to use that too much anymore. Occasionally. Seems to be a rite of passage in Algebra 1, so I will derive the quadratic formula for you in another week or two, but not right now. All right, so this class is all about working with zeros and ones. I hope you do. Multivariable calculus, X, Y, and Z. The world's three-dimensional, it's not two. So what would I work with here? Well, I'm not going to let anything other than 0 for Z. I'm certainly not going to do anything for Z except set it to 0, because if I work with any numbers, I'm getting a positive, and that's not getting me positive 2. So what gets me positive 2? Well, let's let y equal 0. Then I'm only solving x squared over 9 equals 2, and that's plus minus the square root of 18. If I let x equal 0, that might have been easier. If I let x equal 0, then I'm seeing plus minus 2. So there's 4 coordinates. It only took 10 seconds. The 10 seconds it takes to write your answer, if you're learning. All right, and then this course is based on zeros and ones, so I just gave you a chance to work with zeros and ones. If I was working with, what else could I work with? No, I don't think so. Oh, I'm thinking about a test question I'm asking tomorrow. It's already written. Senility, multi thoughts. Better go to some mindfulness retreats. All right, this one here. If I'm doing this problem, I'm going to do it as such on your answer key. I'm going to make a big square root, and I'm going to drop the 6 out, and I'm going to leave the 2 in. So I'm seeing 72 as 36 times 2. So I do each term as I go along. I see x to the 6 is x cubed, because if I square that, I get x to the 6th. Same thing with y. I usually leave a little more space than this. Okay, so I can see y, but that means I still have 1 that I haven't accounted for. I can see 10 of those coming out. Z to the 10th times z to the 10th is z to the 20. One of them stays in. Now, what could I show? Not many things. The smallest one I can show is the square root of 8. If you do the square root of 8, you get a number on a calculator. If you do 2 root 2, you get the same number. Now, this one I kind of know. This is 2 times 1.41 as an approximation. That's what we're using for the square root of 2. So initially, know what I just started with 10 seconds ago. I said I get some number. Well, now I know it's pretty close to 2.82. I think 2.82 is slightly bigger, because I think I forget the square root of 2, 1.407 maybe, I forget what the next decimal place is, but that's okay. I got a feel. X minus 2, well, you think you can just do x minus 5 quickly now. That takes the first 2 terms. That gets me 10, and I want 2, so I got to go down 8 over x minus 2. And since I want to check this right now, because I might forget at the end of the test, if I put a 2 in, I should get negative 8. Because I could have moved that negative 8 to the outside of the parentheses. We've talked about that in earlier lesson sets. So if this is equal, it's a calculation. Let's put 2 in. 4 minus 14 plus 2 minus 10 plus 2. Oh, by goodness, negative 8. I move on. Now, why did I write this? Because in calculus, when I asked this question in calculus for the first time, most people can't integrate that calculation. And yet, I'm really asking what you just did a second ago. There's my x minus 5. There's my 10. How do I get 10 to 2? Minus 8 over x minus 2. And then when you get to calculus and you integrate that, people don't have trouble with that. ln of x minus 2 plus c. Yeah, most people can get that. If I gave them this on a test, most people at the stage of the term that I ask, integrate this, can't answer the question. But if I hopefully get students to learn how to do this, then they can. A little awkward on my part there. Lost my train of thought. Senility continues. Let me move this out of the way. Let's bring Rennie the card into a closer position to the board so that you're not straining your eyes. Okay, hopefully that works. So how do I do a problem like this? I can see that that's positive 21i squared. Positive 21i squared is minus 21. 10 minus 21 is negative 11. And then I've got minus 8, minus 15, minus 23i. But probably at the end of the test, you might want to check that. I think I'm sticking with my answer. All right, 8i to the 29th, you divide by 2, then you got what, 14? So I know this is 8i. And how did I know that? Because I rewrote it as 8i squared 14 times I. And so what is I squared to the 14? I hope everybody sees that as positive 1. Why? Because I'm doing negative 1 14 times. Intersection for this. All right, I don't want the coordinate intersection. Well, I got to find the x values first. The x values, well, I think it's plus 3 and minus 3. I hope you can do that in your head. I hope you can add 1, makes it 18. I hope you can divide by 2, makes it 9. And I hope you can take the plus minus square root. And if I do that, this function tells me they intersect at 17 because it doesn't matter what the x is. Sound like a familiar refrain from earlier in the lesson set? Yes. Now you're going to see me disappear for 10 seconds. I want my coffee. It was such a good cup of coffee, too. Unfortunately, it is now lukewarm. Or as one of our words of the day, tepid. All right, so can you do that in your head? I hope so. I hope you can add 5, 7, 28, divide by negative 3, negative 28 thirds. It's good to do that for practice. So what did I do? I moved the 5 over. If I move the 5 over, this is now equal to 7. If I divide by 4, it's 7/4. Oh, multiply by 4. See, I'm writing it out. I make mistakes when I write it out. Division becomes multiplication. There's 28. Then I'm dividing by negative 3. But we don't like the negative in the denominator. We move it. There's your negative 28 thirds. All right. Can you reduce 28 sixteenths? I hope so. 22 sixteenths, excuse me. Senility continues. 11 eighths. Can you move the a to the negative 5 into a to the 5 in the numerator and say a to the 7? Can you move the 4 into the denominator and say b to the 11th? Hope so. Can you tackle these one at a time? 6 times what is 6? 1. I don't have to write it. Minus 2. Can you look at 3 and 1 and say, I need one of these coming out, but I need another 2 in here? And 22 and 6, I think z to the 6th is common. That takes care of it on the end, but I need another 14, 16 here. That's how I do my answer key. I do each one separately. Moving right along. What can I say about this? Well, it's a 3x and an x. I know that's for sure. I know I have a plus minus, but the question is, which number am I going to put there for factors of 10? Am I going to put a 1, a 2, a 5, or a 10 there? And I want to get close to this number. Well, I can see what I'm going to do now. 2 and a 5. That's 6 and 5, and I think I can make that 1, provided I make that the 6, and that the minus. I think I'm done. What are the answers? I'm pausing the video each time. Hope you're saying minus 2/5, and I hope you're saying 1, and I hope you're not saying 3. Snuck in undefined situation there. No partial credit on this one. Everything's either all right or all wrong. 2/3. Well, if I put 2/3 in there, I got minus 8 thirds plus 6 thirds. I think I got minus 2/3. X minus h squared plus k. I think I've got h plus or minus the square root of k over a. Subtract k. Careless error. Subtract k. Divide by a. Move the h over, plus minus. I think I'm done. Okay. Now, if I wasn't talking to you, wouldn't make that mistake. Oh, that's 50 problems. And the computer didn't crash. I'm a happy man. All right. Well, good luck tomorrow. Whatever you got wrong on this video, I would star it. I would get away from it for half a day. Then I'd come back and maybe on that piece of paper go, why did I make that mistake? Let's hope I don't make it again. And then you see it again tomorrow and we find out. Okay. See you soon.